Hello and welcome to Fun Facts Online. Today, we're journeying to the most remote continent on Earth, Antarctica. But we're not staying on the surface. We're going deep, kilometers deep, beneath the colossal ice sheets to a hidden world that has been concealed for millennia. This is the realm of subglacial Antarctica, a world of immense canyons, vast lakes, and intricate river systems that is fundamentally changing our understanding of the planet. For much of human history, the land beneath Antarctica's ice was a complete mystery, a true terra incognita. Early explorers could only speculate about the continent's hidden topography. The first real clues emerged in the mid-20th century with the development of radio echo sounding, or RES. Imagine a continental-scale ultrasound. An aircraft flying over the ice emits radio waves. These waves travel through the ice sheet, bounce off the bedrock below, and the return signal is recorded. The time it takes for the signal to return tells scientists the thickness of the ice, allowing them to map the shape of the rock beneath. The first extensive surveys in the 1960s and 70s began to paint a picture of a continent far more complex than a flat, featureless plain. But the real revolution came with satellites and advanced airborne geophysical surveys. Scientists now use a combination of tools that work in concert. RES provides high-resolution data along the flight paths. Seismic surveys, which create vibrations and listen for the echoes, can distinguish between hard rock and the soft, water-saturated sediments that often lie at the base of the ice. And gravity measurements help fill in the gaps between flight lines, revealing the underlying geological structures. This multifaceted approach has pulled back the icy curtain on a truly stunning scale. And what these maps have revealed is nothing short of world-altering. Let's start with the canyons. In a region called Princess Elizabeth Land, once dubbed one of Antarctica's poles of ignorance due to a severe lack of data, scientists found something extraordinary. Faint traces were first spotted in satellite images, which showed subtle features on the ice surface that hinted at large-scale topography below. Subsequent airborne surveys with ice-penetrating radar confirmed it, a vast network of canyons and likely a large subglacial lake. This canyon system is thought to be over 100 kilometers long and in places up to a kilometer deep. To put that in perspective, that's comparable in depth to the Grand Canyon, but more than twice its length. This immense network was likely carved by water, either in a distant past before the ice sheet formed, or by the persistent flow of water beneath the ice over millions of years. But that's not even the record holder. That title belongs to the canyon beneath the Denman Glacier in East Antarctica. The Bed Machine Antarctica project, a massive international effort to create a detailed map of the continent's bed, discovered this is the deepest known land canyon on Earth. It plunges to an incredible 3,500 meters below sea level. This feature isn't just a geological marvel, it's a major concern for global stability. The Denman Glacier itself has retreated nearly 5 kilometers in the last 2 decades. This deep canyon could accelerate that retreat by providing a channel for warm ocean water to circulate underneath the glacier, melting it from below. If the Denman Glacier were to melt entirely, it could raise global sea levels by about 1.5 meters. One single glacier, with its fate tied to the shape of the hidden canyon it rests upon. Meanwhile, in West Antarctica, the Polar Gap Project has unveiled 3 vast subglacial valleys. The largest of these, the Foundation Trough, is over 350 kilometers long and 35 kilometers wide. Another, the Patuxent Trough, is composed primarily of unconsolidated sand and gravel, suggesting a complex geological history. These valleys are not just empty spaces, they act as crucial channels, funneling the flow of ice from the continent's interior towards the coast. Their discovery provides vital information for understanding the interaction between the East and West Antarctic ice sheets, which is fundamental to predicting future sea level rise. But these colossal canyons are not just static geological features, they are integral components of a dynamic, continent-spanning plumbing system. So far, scientists have identified over 400 subglacial lakes beneath the ice sheet. They range in size from small ponds to behemoths like Lake Vostok, which is one of the largest lakes in the world, completely hidden from view under 4 kilometers of ice. These lakes form from a combination of factors: geothermal heat rising from the Earth's core, the immense pressure of the overlying ice, which actually lowers the melting point of water, and the incredible insulation provided by the ice sheet itself. And these lakes are not isolated pools. Satellite observations have revealed that many are interconnected, forming a vast hydrological network that transports water across the continent. Some lakes are considered active, meaning they fill and drain over time, sometimes in dramatic flood events. Between 2003 and 2009 alone, researchers identified 124 active lakes. This shattered the long-held assumption that subglacial environments were static. Connecting these lakes are extensive river systems. The discovery of one 460-kilometer-long river showed that there is far more active water flow at the base of the ice than previously thought. These are not gentle streams. They can be vast, high-pressure systems that transport huge volumes of water, reshaping the landscape from below. So why does all this hidden water matter to us, thousands of kilometers away? Because this subglacial water is a critical factor in the stability of the entire ice sheet and its contribution to global sea level rise. The water in these systems acts as a lubricant. It reduces the friction between the base of the ice sheet and the bedrock below. This lubrication allows the ice to flow more rapidly towards the ocean, particularly in the case of ice streams, which are fast-flowing corridors of ice that drain large areas of the ice sheet. While a well-connected system of channels might drain water efficiently, a more dispersed system can increase water pressure at the base of the ice, leading to faster flow. The Thwaites Glacier in West Antarctica, often called the Doomsday Glacier, provides a stark and, frankly, terrifying example of this process in action. It's one of the fastest-changing glaciers in Antarctica and is already a major contributor to global sea level rise. Scientists have observed its network of subglacial lakes draining in large flood events. These events release vast quantities of fresh water into the ocean, right beneath the glacier's floating ice shelf. This fresh water is less dense than the surrounding ocean water, so it creates a plume that rises, drawing up warmer, saltier ocean water from the deep. This warmer water then melts the ice shelf from below, a process called basal melting, which can temporarily double the melt rate and contribute to the retreat of the glacier's grounding line, the point where the ice detaches from the bedrock and begins to float. This is a critical feedback loop, and understanding it is the mission of the International Thwaites Glacier Collaboration, a huge UK-US research program dedicated to this one glacier. The connection between subglacial hydrology and sea level rise is so profound that recent studies have shown that failing to account for it could lead to a significant underestimation of our future. One study, using advanced ice sheet models, suggests that including the evolution of subglacial water systems could amplify ice discharge by up to 3-fold. This could potentially contribute an additional 2.2 meters to sea level rise by the year 2300. The study also suggests that tipping points, beyond which ice loss becomes irreversible, could be reached up to 40 years earlier than previously anticipated. The secret world beneath the ice is an active engine of change, with direct global consequences. This hidden landscape also gives us a window into a lost world. The very existence of these features tells a story of a time when Antarctica was a very different place. For a large part of its history, it was part of the supercontinent Gondwana and had a temperate or even tropical climate. Fossils of forests, including palm trees, have been found on the continent. The Colossal canyon systems were likely initiated by tectonic forces during the breakup of Gondwana as rift valleys formed. Then, as the continent drifted towards the South Pole and atmospheric carbon dioxide levels decreased, the process of glaciation began around 34 million years ago. The landscape we see today is a combination of these ancient fluvial features and the more recent modifications by the overriding ice sheet. Mapping this world is a monumental undertaking. The logistical challenges are immense. Getting to remote field sites can involve long journeys by ship and tractor-trailer. Once there, scientists often live in tents on the ice for weeks or months, facing blizzard conditions and extreme cold. The technical challenges are equally daunting. Drilling through kilometers of ice requires specialized hot water drilling equipment, a complex and time-consuming process. The risk of contaminating these pristine environments is also a major concern, and scientists go to incredible lengths to ensure their equipment and procedures are sterile. Despite these challenges, the quest to understand Antarctica's subglacial world has been a story of remarkable international collaboration, enshrined in the Antarctic Treaty, which sets aside the continent for peaceful purposes and scientific research. And the exploration is far from over. In fact, we are only just beginning to scratch the surface. New technologies, like autonomous underwater vehicles, or AUVs, are being developed. These robotic submarines can explore subglacial lakes and canyons without a physical tether to the surface, offering unprecedented access. Machine learning and artificial intelligence are also playing an increasingly important role, helping scientists identify patterns and features in the vast amounts of data that would be impossible for humans to detect. Many unanswered questions remain. What is the full extent of the continent's hydrological system? How will these systems respond to a warming climate? And, perhaps most tantalizingly, could life exist in these extreme environments? The discovery of these lakes has opened up a new frontier in the search for life beyond Earth. They are considered to be analogs for the icy moons of Jupiter and Saturn, like Europa and Enceladus, which are thought to have liquid water oceans beneath their icy shells. Studying the life that may exist in Antarctica's subglacial lakes could provide valuable insights into the potential for life to exist in these extraterrestrial environments. The exploration of Antarctica's colossal canyon networks is a journey into the unknown, a quest to understand a world that has been hidden from us for millennia. It is a story of scientific discovery, technological innovation, and human endeavor. And the secrets being unlocked from beneath the ice are not just about a remote and frozen continent, they are about the future of our planet. Thank you for listening to Fun Facts Online.